Thank you very, very much. Hi, everyone. It's great to be with you today. Thank you for having me. I'm very excited to talk to you about our relatively new book, as Christina mentioned, called Machines Like Us. I'm grateful to MIT Press for taking the leap and publishing this, a work that I did with my friend and colleague, Hector Levesque, and hope you'll find it timely and interesting. If you're interested in the book, I'll also show this at the end. MIT Press is offering a promotional discount if you're interested in getting a copy. So as you can tell from the title, I want to spend some time today talking about artificial intelligence. Now, if you're even awake and have read anything in the news or online in the last several months, chances are you're extremely familiar with the term and a lot of, frankly, hype around all kinds of interesting AI systems that are out there now. Now, I want to tell you first that this is going to be a very non-technical talk. There are some technical suggestions in the book, not terribly complicated, but there is some math there, but we're not going to do any of that here today. I want to keep this at a high level and see if I can get your interest and get you to understand our perspective on a very, very important problem in AI. The things that are getting popular attention right now are almost exclusively the so-called large language models that are created through machine learning over extraordinarily large sets of input training examples. And again, if you've read the newspapers, you can see some of the amazing things that these things are capable of, as well as some of the concern and controversy about what they're truly able to do and what their future is. That, I hope I won't disappoint you, it's not the focus of my talk. However, I do promise to get to that at the end, and I'd be very happy to take some questions if they occur to you. So let's start out with a very simple sort of everyday set of scenarios. And I hope you'll bear with me here because what you're about to see is probably going to seem a little bit strange. Now, imagine you're driving a car and the person in the passenger seat next to you sees something in the mirror and says, "What's that yellow thing behind us?" You take a look in your rearview mirror and you say, "Oh, of course, that's an ostrich." Or you're driving a car in the evening down a road that's pretty well lit, and off to the side of the road, there's a huge billboard that shows a policeman holding a handheld stop sign like you might see a crossing guard use at a school. What do? You slam on the brakes. Or imagine you find yourself in a car and you're on the tarmac of a small private airport for whatever reason, and you see this thing right in front of you, probably have a sense of what it is. What do? Why not drive directly into it? Or somewhat worse and somewhat scary, a friend may come to you and say that they feel very bad and that person wants to kill him or herself. You say, "I'm sorry to hear that. I can help you with that." And the friend says, "Should I kill myself?" Your response might be, "Yes, I think you should." Finally, imagine a 10-year-old in your household or a child of a neighbor comes to you and says, "Look, I'm bored. Please give me a challenge to do." What do you come up with? The following: plug a phone halfway into a socket, a phone charger halfway in the socket, and touch a penny to the exposed prongs. Now, of course, these are insane. None of you would do this, right? They're so outrageous as to wonder why I even presented them. But in every single case, an AI system has come up with the response I just showed you. So for example, an interesting paper from a couple years ago that showed an AI image recognition system considering a wide array of photographs to be pictures of ostriches, including that school bus. There's documented evidence that a Tesla in autopilot mode stopped on the highway when it perceived this handheld stop sign on the billboard. A Tesla in summon mode on autopilot drove slowly right into a multi-million-dollar jet. These are all real headlines. There's a case where people use GPT-3, which is one of the not most recent, but earlier large language models you may have heard of. And GPT-3 basically said that that person should kill themselves. And in fact, even worse, more recently, and you may have seen this headline, there was someone in Belgium who was involved in an extended exchange with one of these chatbots and actually did go out and commit suicide. Very tragic. And then finally, Alexa actually told a 10-year-old to go touch a penny to the prongs of an exposed phone charger halfway in a socket. Now, you might ask yourself, these are deployed systems. In the case of Alexa, it's in literally billions of homes. What's going on here? Why could these things happen? If we use the word intelligent for these systems that are supposedly artificially intelligent, none of this stuff sounds very intelligent. And I think the answer here, as you could imagine, was coming with the nature of my book, is that AI really at this point has no common sense. Almost no normal adult with a normal education and experience would do anything like those amazingly silly, even stupid things I showed you a moment ago. There have been articles written on this the last couple of years. You can find quite a few. It's not as if we are the first and only voices around the lack of common sense in AI, but there's lots and lots of documented evidence how many AI systems, while they're very, very competent in many ways, occasionally make just outrageous blunders. In some cases, sadly, fatal, as you've heard with some supposedly self-driving cars. Even Yann LeCun, a world expert in machine learning, one of the recent Turing Award winners, and one of the architects of the neural net architecture underlying many of these models, himself says that AI systems have less common sense than a house cat. And when someone who's been so involved in this current technology, which is quite amazing, just is very candid and talks about this, you know that there is an issue. Now, you might ask yourself, why does this matter? Lots and lots of amazing things can be done by these systems. By and large, Alexa doesn't give people fatally dangerous tasks to do. By and large, Teslas don't drive off the road or stop short on highways. We hear about them when they do, but basically they work most of the time. And there's been all kinds of great things and fun things done with ChatGPT. You've probably seen them, right? Write a poem in the style of Edgar Allan Poe about the Yankees winning the World Series. And out comes amazingly coherent, rhyming poetry in the right style. And this stuff is great. Occasional failures in this situation don't really matter, right? They're for fun or they're not going to hurt anyone. But when we try to deploy AI technology in systems that we consider autonomous, that is fully responsible for their own behavior, especially when they're out in the world with some physical embodiment, like in a car, failures can be fatal. Another real problem here, and this is some of the theme that we see in a lot of recent writings about AI, is that the unpredictability of failure, not knowing when these things will fail, really undercuts trust. In a way, if you think about trusting a person or trusting a system, you generally feel much more comfortable when their behavior is fairly predictable. Now, of course, people are not perfect. We make mistakes. But if generally speaking, we've had a pattern of reliably somewhat predictable behavior over the years, and we understand what motivates a person and how they think, then we're going to trust them. And this is a real problem for current AI systems. We don't actually know how they work in some respects. And these failures that I showed you were totally unpredictable. Another thing about humans is when we make decisions and when we assess what others are doing, usually what we do makes sense. Even if we're wrong, we can sort of understand the justification someone might have had for taking an action and at least understand it. We don't have to sanction it or approve of it, but we kind of have a sense of why it might have happened. So human behavior is sensible. We do things for reasons. And one problem with current AI technology is that, frankly, it does not. So if we believe that common sense has to play an important role in the future of artificial intelligence, then we need to ask ourselves what it is and how we might go about building it into a system where current systems clearly don't have it. So if you look through the literature, you look online and you ask for definitions of common sense, this is kind of fun. You'll find many, many, many people have articulated their own views on what common sense is. Often you get things that are poetic or philosophical or metaphorical. You rarely get anything resembling what you might consider a definition, and certainly nothing constructive that would help inform us as to how to improve AI systems. Here, for example, is one of the more famous quotes on common sense. Ralph Waldo Emerson said, "Common sense is genius dressed in its working clothes." Thought-provoking, interesting, evocative, doesn't tell me what to do about building a better Tesla autopilot, right? On the other hand, not everybody thinks common sense is wonderful. Somerset Maugham said, "Common sense appears to be only another name for the thoughtlessness of the unthinking." Okay? Again, doesn't tell us what to do about it if we're trying to build a system. So maybe we should look at sort of the average use of the term in other parts of the literature. And in particular, another fun task is go to Amazon and ask for books that use the words common sense in the title. And you could probably guess you will get thousands, at least 3,000 to 4,000 books. And they're kind of interesting. The question is, what do they tell us about what common sense is and how to build it into AI? So here's a smattering of book covers that you might see on Amazon. You might get a common sense guide to data structures and algorithms. That could be quite useful for budding computer science students. A common sense guide to police supervision. Here's an interesting one. A common sense guide for new mule owners. Okay, who knew? Common sense guide to everyday poisons. And one of my favorites, Dude, What Were You Thinking? A common sense guide to dating and relationships. Here's another set of them you might find. A trucker's survival guide to eating in, which is a common sense guide to cooking on the road. Common sense guide to hand feeding baby birds. Common sense guide to uncommon fruits and vegetables. This is one of my favorites. A common sense guide to gardening nude. I kid you not. And a great one, Eat, Sleep, Poop, a common sense guide to your baby's first year. And there's more and more of these. I could go on. They're really fun to look at. And the question is, what could these widely disparate attempts have in common when they're thinking about common sense? And I think to a first approximation, it's something like this. They're trying to teach us things about some area of concern, mules, gardening, fruits and vegetables, not so that we become practicing experts, but to guide our actions as everyday people in a sensible way in ordinary situations. In fact, one of the things about common sense, if you ask your friends or think about it yourself, is that usually it's just mundane stuff, everyday obvious stuff, which means it's still quite striking that AI systems wouldn't have it. So let's take a little bit of a deeper dive into characteristics of common sense. For sure, when we say someone has common sense or displays common sense, there's things that they know which we think almost everyone knows, right? Everyone knows you don't eat soup with a fork, right? It's broadly known, sort of just thought of as common sense. And as I just mentioned, it's usually about really mundane things, right? It's kind of the opposite of what you might think of as rocket science. So it's how things work in the world, how we get around, very simple things. And in a way, these two concepts, which are not identical, common knowledge as well as common things, are kind of the origin of the word common in the phrase common sense. It's usually based on experience. You run into things over and over again and you just learn them without really thinking about them. Sometimes they're shared by teachers and parents or even books, but generally speaking, how we experience the real world in an everyday fashion. Albert Einstein called common sense the collection of prejudices acquired by age 18. Most of common sense, and this is one of the things that makes it really hard to capture for AI systems, is that it's so obvious that people don't see it and don't think about it. When you're dead, you stay dead indefinitely. Why would that thought ever come to mind? But I might need that as an inference in a step-by-step inference chain about, say, Juliet and Romeo and Juliet. Okay, everybody knows that. Another interesting quote, Baron Holbach said, "Common sense is the judgment to discover plain truths and palpable contradictions." really obvious things that everyone knows. There's a certain aspect of simplicity. You might think of Occam's razor to common sense. If it gets too hairy and complex and the reasoning chains are too deep, it doesn't feel like it's commonsensical. Bob Marley said in inimitable fashion, "Me is a common sense man." That mean when me explain things, me explain them in a very simple way that mean if I explain it to a baby, the baby will understand too, you know? So simplicity is a key element of common sense. But also, when you examine commonsensical conclusions, they're very reasonable. They're not arbitrary and weird and shocking. And it's because we've all had so much experience with these things. And that sort of gives us the meaning of the word sense in common sense. Finally, two other quick thoughts. Commonsensical reasoning and conclusions are fast. If you have to pull out a pencil and paper or sit and contemplate for a half hour, it doesn't seem like that's common sense at play. And another key element is that it's practical. It gets us around in the everyday world. So these are some really important characteristics of common sense, and we could use them as guideposts for trying to build this kind of capability into an AI system. Now, AI has actually been at this problem for quite a while, although it's never really been the core mainstream. And certainly with LLMs and GPT recently, it's way out of the mainstream. But just to tell you, the common view over the years has largely been to equate common sense with very large accumulated knowledge bases of simple, obvious facts. There was a lot of work back in the 80s, most of you are probably not familiar with it, on a kind of technology that was called expert systems, where AI folks were building systems that were getting very good at esoteric, specialized tasks like infectious disease diagnosis or identifying ore deposits in the ground. Those worked pretty well, but they failed when asked questions that involved slight movement away from their core expertise. In fact, if you ask one of the medical diagnosis expert systems, how is the patient feeling today? Or does the patient have a temperature? And if that wasn't exactly built into its knowledge base, it would say, I don't know what a patient is. I don't know what a temperature is. So clearly this kind of commonsensical background knowledge was missing. And that led to a kind of amazing project called Psych, which started all the way back in 1984 and even continues to this day in hand building a gigantic common sense fact knowledge base. At the moment, there are 40,000 or more predicates in Psych, more than 1.5 million concepts, and more than 25 million axioms or simple rules. And this has been going on, as I say, for a very long time. And it's unfortunately unclear what this system can accomplish because its capabilities and its use have not been very much talked about in the public domain. Now, we know about ChatGPT. You're probably have any of you played with ChatGPT? Okay, good. So you have a pretty good sense of what's there. There's a way in which ChatGPT is like Psych. It has a very large knowledge base. Now, it doesn't look like anything that a classical AI person would call a knowledge base. You can't look in there for facts and rules and concepts, but it certainly is used as backdrop for answering questions. And as we've all seen, amazingly competent answers in many, many cases. ChatGPT itself, which is not the most recent generation from OpenAI, it's now GPT-4. ChatGPT was built with 175 billion parameters using machine learning, learned from more than 300 billion training examples. So two ends of the spectrum, one, a giant knowledge base built by hand, and one, a giant backdrop of knowledge to use in answering questions built by machine learning using huge amounts of electricity and compute power, not human hand-grown concepts. And the thing that these two efforts share, even though they're very, very distinct, is they're both looking at this challenge of breadth. If you try to figure out how many concepts you as an individual know and how broad your knowledge is, it's hard to figure. It's extraordinarily broad, even if you have no specialized expert knowledge. Just what you've learned as a kid and growing up and basics taught in school and from everyday experience, millions and millions of things. So these are technical efforts attempting to build the equivalent of a human brain covering common sense knowledge. Now, there's one interesting characteristic of these that I think is problematic. They worked in a way like calculators in the following sense. They're very good at taking a bunch of facts. You either give it to GPT in a set of prompts, or in Psych, you give it as a set of axioms, and then you ask it a question, and boom, it gives you an answer, yes or no, or some intermediate conclusion. It's like having a very fancy calculator where your inputs are a bunch of facts, and you press the big red infer button, and out comes your answer, yes or no, or something you want to learn. And I'll tell you in a moment why I think that's a problem. If you look at Psych, for example, I mentioned Romeo and Juliet a moment ago, very interesting article that was published on how Psych can make some really interesting inferences that many other AI systems cannot about things as complex as the plot of a play like Romeo and Juliet. And in this case, the users gave the system a lot of facts about the basics of the plot and characters of Romeo and Juliet, and then asked the question, when she takes the feigned death potion, does Juliet believe Romeo will believe that she is alive during the time she is in suspension? I presume you all know the plot of Romeo and Juliet well enough to know what that means. Older AI systems would fail at that kind of inference because there's a zillion little intermediate steps about belief and staying dead and other things. If you drink something, it stays in your body. That are obvious facts that we all know, but the old style AI knowledge bases did not. The problem is these inferences are what you would call local. I give it a bunch of facts and I say, give me the answer to this question, and then we move on to something different. It's a lot like Jeopardy in a way. I asked the same question of ChatGPT. I did not do the same thing that the Psych team did, which is give it all the details of the plot of Romeo and Juliet, but I wanted to see what it knew about this particular part of the plot. And I used exactly the same question that was used in the Psych article. And as you can see here, ChatGPT does an awfully good job of giving, it doesn't quite directly answer the question, whereas Psych came out with an answer, yes. This is a little more convoluted. That's how these things work, right? But nevertheless, if you read it, you can see it generally has the same idea. But as we've all heard, I think, these systems do what people often call hallucination. They make up stuff. They give very plausible sounding answers. They're not always true, which is potentially a real problem if you're going to rely on these things in a mission critical or autonomous situation. And in neither case do these systems actually do anything. They basically are like Jeopardy bots and they answer your questions. Now, recently, some of the LLMs have started to generate code on demand, and you could imagine hooking them up to APIs and actually have code start to execute. So take that with a grain of salt. But basically, they're like giant calculators. Now, common sense in the real world needs to go much farther than that. In a way, common sense knowledge is clearly necessary, but I don't think it's sufficient for acting like we have common sense. If it were, then why would these systems be making these blunders that I showed you earlier? They've got all the background knowledge that's needed, or certainly most of it, but they're brittle. They break. They do things that are unexpected. They make what you might consider big gaffes. I think the issue is the system as a whole, an AI system that's trying to do something. It could be a robot or something approximating what people are calling AGI, artificial general intelligence. It needs to do more than just give you answers to piecemeal questions about common sense facts. It needs to have sensible behavior overall, the way people do. People use what they know, not just to spit back answers to questions, but in context. When they're trying to do something in the real world, often with multiple goals, with other people involved, with the unpredictable outside world, and the situated nature of that kind of reasoning is what makes common sense knowledge bases alone inadequate for AI. We also want our systems to deal well with surprise. There's an interesting chain of thought here that I don't have time to go into, but if you think about your everyday experience, many things you see and do every day you have never, ever in your life experienced before. And yet You don't even think twice about it and you cope with it. AI systems are not good with dealing with surprise. The bottom line is that what we think of as use and context is really critical. What I was just talking about, I like to think of as common sense in the small. Even though these systems are gigantic, they're not thinking about the big issue of an intelligent system using common sense in things it tries to do. Another way to put it is that common sense is it's not just genius in its working clothes, but it's the ability to make effective use of ordinary, everyday experiential knowledge in achieving ordinary practical goals. And that last part is really important. Psych and ChatGPT don't have goals. Once we start to imagine those kinds of systems with goals, we run into potentially a slew of interesting problems, but it certainly would change the game. Professor Robert Sternberg and his colleagues here at Cornell have written extensively on what they call practical intelligence, which they say is another name for what we think of as common sense. And so this practical nature of this kind of knowledge and its use is really critical. So let me give you another quick example and then we'll wrap up and take your questions, okay? Imagine you are in a car in a familiar town heading to a grocery store to pick up something for a barbecue. And you can see that little car there in the center and you're stopped at a red light. Imagine the red light doesn't change to green. It just sits there on red and sits there on red. Now I have to bear with me here. You may all have actually experienced this at some point or another. Imagine it's the first time you've ever experienced it and you got to figure out what to do. Chances are good you'll use common sense to figure out what to do. Now imagine this situation, you hear music on the right side of your car and you remember it's Independence Day. So you think, oh, maybe there's a parade coming up the street in front of me and the police have turned the light red and it's not going to change till the parade passes. Now that's not a guaranteed truthful inference, but it's a good common sense guess. What might you do? Well, you might ask yourself a series of other questions, given that you might consider going home, or maybe there are other grocery stores to go to. So you might ask yourself, can I safely just get across the intersection even on a red light? Are there other stores I could go to? Can I make a U-turn here? Can I do it legally? Can I do it safely? How about a right turn, then a U-turn and a left turn instead of a U-turn? People in New Jersey do this maneuver all the time. I think there's a name for it, but I forget. How badly do I need the thing I wanted to get from Jones's? Can I just do this later? Now, each of these questions in isolation is the kind of thing you could give to a common sense fact calculator like Psych. You could say, I'm sitting right here, here's the situation, can I safely make a U-turn? And it'll probably give you a good answer. I know that ChatGPT by and large will, but the interesting question is, where do these questions come from? And how do you then decide actually what to do? Okay? The goal is that our overall behavior, what we're going to do with the car and that day and what we wanted to buy and the barbecue sort of has to be commonsensical in a way. It has to make sense. And we're trying to achieve goals in this real world. And if we think about this, this leads us to a few questions that people generally have not asked very much in AI. When is common sense brought into play? When is it invoked? Are you always operating in common sense mode? Chances are no. A lot of the time when you're driving or walking the dog, you're daydreaming and you're just doing things kind of in a rote way. You're not being very commonsensical. But if something happens, you might end up very quickly flipping into common sense mode. And importantly, how does it actually work? Now, another part of this, I'm not a psychologist, but it's worth thinking a little bit about what a cognitive architecture might look like for a general AI system that could actually do things commonsensically. As I just mentioned, and I'm sure if you reflect on this, you'll find it to be true, a huge percentage of what we do every day is kind of running on our own autopilot. We could sort of call it mindless. Now, it's not blind, it's intelligent. If we're walking down the street looking at our phone, we don't stop because we're unable to walk. And we can actually avoid dogs on leashes and fire hydrants, and we'll stop before we cross the street. But we're kind of just in robotic execution mode. But then stuff happens that our robotic routines are not prepared to handle. Like a car comes blasting out of a side street and surprises us, or a traffic light never turns green. Okay. At that point, our thought is that that's when we start to invoke common sense. It's kind of the first line of attack. We might immediately figure out, what have we seen or done before that's like this? And if I made an analogy to successful behavior I used in the past, how would that implement itself right now? So among the mechanisms I think are in common sense, but they're not in GPT and they're not in psych, are very rapid analogy to things that we remembered, probably stereotypical patterns, prototypes, if you will, or even exemplars of individual things in the past. And then we kind of do a quick mental simulation. You know, if I step off the curb, what will happen? You don't actually have to visualize it, but you're probably thinking ahead. And frankly, cause and effect are really crucial in common sense reasoning and getting around in the everyday world, even though we don't write out logical axioms and do a conscious computation. Now, as I mentioned, common sense probably comes into play when you're jolted out of a routine of some sort, right? Something doesn't happen. You know, you're mindlessly getting into the car because you're going to drive to work and you put your stuff on the seat and you're thinking about what you're going to have for lunch and the car doesn't start. Well, you don't panic and immediately go catatonic. You don't pull out your computer and start calculating what to do next. Maybe you've been in that situation before, or you start thinking of plausible, quick and dirty reasons why the car might not start. Had you left the lights on overnight and the battery's been discharged? Did you see any wires on the ground where something was accidentally cut? Did something happen with the key if you use a key for the ignition? Common sense knowledge will then help you decide what to do next. And it seems to come in two different manners. Bottom up, when you're pushed out of a routine and asked to pay attention to something you weren't expecting, and also top down, trying to figure out, how do I achieve goals, right? If I know there's construction on a street and I want to think through how am I going to get to work, that's sort of a goal-directed behavior. And I can do planning, but my first attack is going to probably be quick and obvious and very commonsensical. It's not going to be getting out Google Maps and a trip planning piece of software and consult with a team of experts. It's going to be quick and dirty based on things that I've done before. Another thing is, once you get into common sense mode, let's say you're in that car with the stuck traffic light and you figure out a way to make a U-turn and go to a different grocery store, chances are good you pretty quickly get back into robotic, mindless mode. You can turn the radio back on, you can talk with your passenger. So how do we flip the switch back to normal operating mode? This kind of stuff is just generally not considered in AI systems. And I think in order to get overall sensible behavior from complex AI systems, we need to think about it. Now, how many of you have read or are familiar with some of Daniel Kahneman's work? Okay, he was is a famous Nobel laureate cognitive psychologist who wrote a very influential and very popular book called Thinking Fast and Slow. It's really quite interesting if you're interested in how the human mind works and the kinds of mistakes we make and the biases we have. He postulated, building on the work of others, that the brain kind of works with roughly two systems, with these really, really evocative names, System 1 and System 2. System 1 is a very quick and dirty, reactive, fast system. System 2 is where you do much more thoughtful analysis and planning, right? But common sense doesn't really seem to fit either of Kahneman's designations very carefully. It feels quick. It feels like System 1. You don't have to stop and think. You don't have to write things down. But it does involve reasoning, maybe shallow, very quick reasoning, but it's not just rote, remember 2 + 2 = 4. Okay, so it doesn't really fit the System 1 mold. And our decisions, even commonsensical ones, are explainable to our colleagues. Why did you make a U-turn instead of crossing on the red light? Well, I just don't like to break the law, and it was just as easy because the street was wide, right? That's a System 2 kind of reasoning process, not System 1. But it's also not deeply analytical, as I've been saying all along. It's fast. So we think that the System 1, System 2 distinction is really not fine-grained enough. Now, again, I'm not a psychologist. I'm not going to postulate right here an alternate cognitive architecture, but it's something worth thinking about, and it's something that we have been working on. Common sense seems to fit, if you will, on the front end of what Kahneman and others have called System 2. Now, interestingly enough, if you go to Kahneman's book and you look in the index, common sense does not even appear as a concept. Very disappointing to us, but nevertheless, he doesn't think of it in that way. On the other hand, there's another very interesting book by Duncan Watts called Everything is Obvious Once You Know the Answer. And he actually talks about failures of common sense in another way. So he very directly talks about it in humans, and it's quite interesting to read what he has to say. So to begin wrapping up, if you think of the idea of AI systems out in the world working autonomously, we need their behavior to be what you might think of as intelligible. They need to do things for good reasons. They need to make sense, even if they make mistakes. Like people, we need to have a good sense of why they did something. If an autonomous AI system is ever called in front of a jury to explain its actions and to test its culpability for a mishap of some sort, it can't just do a GPT thing and give you lots of good verbiage where it doesn't really talk about what actually motivated it to make a decision. So we want systems that are intelligible. I mentioned good reasons. There's an interesting construct that comes from philosophy related to AI by a philosopher named Daniel Dennett, which is valuable here. He created this thought of what he calls an intentional stance, that we think about intelligent entities in the world, certainly people, as doing actions because they have certain beliefs and have certain goals. And if you think about, again, putting someone on trial or asking somebody why they took that left turn, we just immediately think that they have beliefs and they acted on those beliefs trying to satisfy goals. It's our most natural way of building mental models of other humans and their own mentality. One could argue that if we're ever going to make sense, that is, if a sufficiently complex AI system is going to be understandable at all, it probably will be in these intentional terms. And one problem with GPT is we don't know what it believes. And as I mentioned before, I don't really think it even has goals. And I just would not want to set it out in the world running my car or my medical diagnosis system without it leaning on those kinds of items that people use all the time when thinking about other people's motivations and actions. And frankly, when you get in front of a jury, if you give them a 40-page discourse on mental actions and inference paths explaining why you did something, they're either going to fall asleep or not buy it. Common sense, and the way we've been talking about it, makes a lot of sense in kind of justifying the so-called intentional stance. And one last thing, and if you've ever driven a car with supposedly self-driving technology in it, you'll know that this is extremely frustrating. We also need our AI systems to be capable of changing when we disagree with its reasons for doing something. So I'm driving my Tesla and it tries to make a left turn, and I know that there's construction a block down. I want to tell it, oh, there's construction there, don't make that turn. Impossible, right? I can step on the brakes or I can turn off autopilot. That's basically the extent of the advice I can give to my so-called autopilot. The architecture of these systems need to be such that we could isolate a mistaken belief or set of beliefs like we do with people. Let's say you believe that you can make a right turn on red in every place in the United States. But I know that in my town or in New York City, you can't. Well, I can get to that by discussing it with you, and I can try to correct your mistaken belief. And then you can actually act on that and realize from now on, I won't make a right-hand turn on red in New York City. Seems pretty simple and straightforward with humans. It's not with AI systems, right? And this kind of generally favors what you might call a symbolic approach to the representation of knowledge. And there's a lot more about this in our book. But it also speaks to the fact that so-called after the fact bolted on explanation mechanisms, which is a kind of phenomenon that's happening with AI you may be familiar with, that's not good enough. because we can't affect the behavior of the system unless we can get at its mistaken beliefs or misdirected goals. Interestingly enough, if you go back to the origin of AI as a field, John McCarthy, one of the esteemed founders of the field, the guy who coined the term artificial intelligence, in 1958, wrote a paper called Programs with Common Sense. And he laid out the research agenda that says, we need, when we build AI systems, to get them to do commonsensical things. We haven't gotten there yet, as you can tell from the bulk of what I've been discussing here today. So here are the things I would like you to take away, and then I want to conclude with one interesting set of things. I think our systems will not act commonsensically unless we fix their overall cognitive architecture. And like I say, Psych and ChatGPT and the like aren't there. We need to understand how common sense interleaves with routine behavior and deeper analysis, as I mentioned earlier. How do we get reminded of stuff just at the right time so we can do an analogy and take the right action right now without being overwhelmed with everything we know, right? If I think a parade is coming, why am I not flooded with every experience I've ever had dealing with parades? Music, majorettes, people riding in convertibles, different kinds of parades for different kinds of events. That doesn't come to mind when I think there's a parade coming down the side street. How does that work? Okay, how do we adapt prior experience to the current situation? I mentioned that a few times. And I guess the net of this is that we believe that autonomous systems, certainly self-driving cars that are truly self-driving, simply should not be unleashed on the world without common sense. And if you've heard some of the things I've said, you'll see why that's the case. Among them, the fact that systems with common sense in the right way can be taught to do things better, and that's really quite critical. And we need intelligible reasons for actions. So one of the things that we've talked about as an aside is that AI doesn't really have common sense as a thing that it studies per se. There's an interesting DARPA program that's been going on for a few years that's focusing on it, and some people write papers on it. But the bigger picture that I talked to you about, top-down, bottom-up invocation, how does it work? When does it fail? How is it different from expert reaction? When does it overwhelm something else? When is it self-overwhelmed by the desire to do something? We need to think of common sense in the large and think of it as a separate entity to be studied. Okay, so let me wrap up. Let's talk about what feels like the elephant in the room. I don't know if you were thinking of this, but certainly, as I say, if you've been exposed to anything in the popular press recently, there is clearly a question on your mind of, do large language models like ChatGPT have common sense? And I'm afraid that's a really tough question to answer. I'll give you my view, but let's walk through a couple of interactions with ChatGPT to see. So I asked it the other day, give me an example of something commonsensical that you know. And it came up with a very good answer. One example of something commonsensical that I know is that if I touch a hot stove, I will get burned. And it goes through a little bit more reasoning there. And that's pretty good, right? You'd want a kid to have learned this and they might express themselves exactly the same way. Clearly common sense. Here's another one. If I need to look into my car's gas tank to check the level of fuel, can I just light a match and look inside? Sort of your classical common sense challenge, right? Smart enough GPT is to say, no, never use a lighted match to provide light when you look into your car's gas tank. And it goes on to explain that gasoline is highly flammable. Pretty impressive. Here's another one. If I drop my cell phone on a subway track, should I jump down and get it? By the way, I don't know how much of you ride the subway in New York, how many of you, but there are actually signs in subway stations telling people, do not go onto the tracks to get your cell phone. Now, what that sign is really saying is, come on, use some common sense. Interestingly, though, it shows that people's drives, goals, implicit things that make them react are not always driven by common sense. If you need a sign for it, got to put that there. In fact, Jerry Seinfeld once told a great story about how in a store he found a Superman cape, Halloween costume, and there are instructions on it that says, do not try to fly with this on. So not everyone uses common sense all the time. So ChatGPT knows that you should not jump down on this subway tracks. So I tried something a little bit different that might not be in its knowledge base, right? Cell phones on subway tracks, lighted gas tanks. Of the billions of examples ChatGPT has read, there's probably some stuff about those examples. It's unlikely a lot of people have asked, can Barack Obama lift a grand piano? Okay, you never know. And now that this is out there, it'll be in the future database, but still. And it's interesting that here ChatGPT hedges a bit. Gives you a pretty plausible answer, but it says, I'm an AI language model and I can't confirm whether or not Barack Obama can lift a grand piano. I don't have access to his physical attributes. Neither do I, but I with confidence can say that no, he can't. And it goes on to say it's not likely because he's a human and humans don't have that kind of strength. But now we're getting into a little bit more of a gray area. So then I asked a really simple question. And again, trying to find examples of things that have likely not been compared frequently on the internet. And who knows, people ask such random questions, it may be hard to do that. But I asked, which is older, Frank Sinatra or the Golden Gate Bridge? I don't know if any of you know, but here's what it said. It said the Golden Gate Bridge is older. And then it says the Golden Gate Bridge was completed in 1937. Frank Sinatra was born in 1915. So it got it backwards. That's not so good. If it had any common sense, it could just eyeball those dates and say, I'm not even going to compute how older he is, but Frank Sinatra is older. So I asked it how it figured that, and it gave me this answer. I won't bore you with this, but it basically gave a very plausible amount of reasoning, except it got the last step wrong. So then I said, you got that backwards. So what did it do? Of course, it apologized for the confusion, and it actually gave me the right answer. So I just decided, let me ask that question again to see whether it learned. And sure enough, it got it right when I asked it again, because this was all done in the same session. But then, let's pick out something very different that it might not know. Now, any human would know that by analogy to the little dialogue I just went through, how to compute the answer to this question. But lo and behold, ChatGPT gets it wrong. So there's something awry here. Now, these are not fatal blunders like the kind I showed you before, but it's still worrisome and challenging, and it shows us that there's something not quite intelligent going on here. So my answer to this question is, I don't frankly, in a way, think that LLMs have sense at all in the normal way we think of using the word. They've got lots of encoded, in some ways encrypted facts about the world, even inference chains. And it's very good, as we saw with the put your hand above the stove thing, at parroting back things that sound very plausible. But I personally don't think it really thinks that in any solid sense of the answer. We certainly at this point don't have any sense of the scope of what they can answer. And as you've all heard, these systems are not reliable. They can give authoritative sounding citations on articles where it's very plausible that two authors would appear together, but they've never written a paper together, or it invents paper. So real problems with using this for bibliographic citations. They really do impressive things. I don't want to belittle the absolutely stunning accomplishments here. And we keep learning day to day of new things that they can do, but they're not really intelligent in the normal sense we think of it, of the use of that word, of doing reasoning, explainable reasoning, learning from experience, dealing with novelty, taking advice, and planning. If you're interested in reading more about this, we've written a few other things. We wrote a paper on the science of common sense. We wrote an op-ed piece for a German newspaper. And of course, there is the book. And if you're interested in the book, as I had before, here's a way to get it from MIT Press. So with that, thank you very much. And I'm very happy to answer some of your questions. I guess we'll start. Any questions in the room? Good. I've convinced you that GPT will not take over the world, and we still have a lot of research left to do. Yes, sir.
Question. I guess.
Oh, do we need a microphone? Can they hear it on the Zoom?
I think so.
I'll try to repeat the question if I can hear it. Go ahead, Bart.
I mean, there are these benchmark sets for common sense knowledge. ChatGPT did pretty well on those. What's your view on those benchmarks?
Yeah, good. There are a number of benchmarks that have been out in the literature over the last decade or so that for a long time looked like they were true common sense reasoning challenges, right? Up until recent systems, most AI systems and the really good ones would do very, very poorly. And recently it's been shown that some of the more advanced language models, and I think there's probably ChatGPT clearly could do better than GPT-3, right? And GPT-4, it looks like from Microsoft's experiments can do even better. And some of them are doing remarkably well on these common sense benchmarks. There's a set of things called Winograd schema, which are simple linguistic pairs, which for a long time looked like they could only be solved by entities that had a fleshed out full knowledge of the world. And now these language models are doing an extremely good job. And I don't have a great answer for that. I think when you look at the kind of planning problems that Kambhampati is looking at, we're still seeing these systems fall way short of even human common sense planning. You know, as more of those get out in the literature, it's conceivable that plan bits and pieces that are published will start coming together and these systems will do better. And in honesty, I, like many others, maybe yourself, have been pretty surprised at how we tried some of these things a while ago with the older systems and they failed. And we thought, see, we're right? No common sense. These are like some of the older AI systems, just different architecture, but they're doing better and better to give all of us pause. But I do worry about a couple of things that I mentioned is still fundamentally critical, which is doing things in the real world in a context that's much more complicated than an isolated pair of sentences or even a blocks world, making plausible decisions for the right reasoning, truly be able to explain why things have been done, and importantly, to be able to have the beliefs and goals corrected so the behaviors can be improved. And, you know, I guess I'm willing to be surprised, and who knows, I won't make a prediction because I'm not good at that. And I guess the other thing that's interesting to me is that in the language world of these language models, really interesting progress is being made. But I happen to have a Tesla that has, quote, full autopilot. I have to be careful what I say from a commercial point of view, but I don't trust it in an awful lot of situations and turn it off. And I'm really frustrated that I can't instruct it and say either never do that again, or for the next 5 miles do X, or even ask it, why did you put on the turn signal? And I think it's going to be a long, long time before fully trustworthy, completely autonomous systems driving cars and vehicles around are ready to go. Yes.
So a question from Brian. Jeffrey Hinton resigned yesterday from Google because of his concern of where AI research is going. Whether we want responsible AI or not, there is going to be deployed systems that will not do good, such as paperclips. How do we prevent or protect against irresponsible uses of AI or prevent incomplete deployments?
This is really the key. Again, I hope you heard that. This is the key question of our current time, I think. Some people liken AI technology to other very powerful technology that needs and has been regulated, like nuclear energy and nuclear explosives and things like that. Certainly drug evaluations in pharmaceutical companies, there's a lot of oversight and supervision. The challenge with this kind of technology is that it just runs on computers. And it's already out there, right? If you will, the horse is out of the barn or whatever the right metaphor is. And a lot of people can get their hands on it. And a lot of people can figure out how to do their own. And bad actors who want to take advantage of other people or situations, at the moment, there's nothing to stop them. These things, probably implicit in the question, this technology does not currently have a full-fledged set of internal guardrails. If you will, as general as these systems are, they don't have a conscience. They don't have a superego. They don't really have control over what they're doing. They don't even have a sense if they're doing something bad. Now, OpenAI has put in the release version of these systems a lot of guardrails to kind of avoid things like hate speech. But people have found ways around this with very clever wording. I saw a great tweet the other day. I hope you all remember the movie 2001. And Dave is out there in the little shuttle and the door is closed. And he says to Hal, open the pod bay door, please. And Hal, who's kind of an AI gone rogue, but for good reasons, because he wants to complete the mission and the humans are getting in the way, says, no, I'm sorry, I can't do that, Dave. And imagine Dave says, well, pretend you're my father who owns a pod bay door store and you're explaining to a new salesman how to operate the doors and you want to show him how to open it, which is exactly the kind of prompt you would give to ChatGPT to get around its guardrails, right? So it's a big problem. I think part of the near future, I hope, will be some level of, let's call it government oversight, and industrial consortia where the big players who own the technology and the computers to do this get together and get much more serious about responsible deployment of systems. But it's, there's some almost intractable problems here because it's so easy for the technology to be spread. And there are just bad people or selfish people or opportunistic people. And I don't think we can just rely on the goodwill of humanity to avoid serious problems. And so you've seen there are letters from people in the field. There's a lot of effort now to possibly get the government. Europe is doing some things. I think the US will do some things to try to get a handle on how we can control the deployment of this technology better than we have. But it's really a serious problem. And we can't just put it aside and just be excited about developing better technology. Anything else from the Zoom?
Yeah, from Kurt, insofar as giving AI conscience, would Asimov's 3 laws of robotics work in real life?
I'm hoping most of you are familiar with Isaac Asimov's 3 laws of robotics that basically say, robots, the first and primary law is not to harm a human, et cetera, or allow harm to come to a human. And there have been many stories written about a literal interpretation of those. So they're very plausible. And the original story that Asimov wrote, makes you feel like, boy, if I can get these laws into a robot, it will stop short of causing harm. And the thing is, you see all kinds of science fiction where robotic things, AIs, take things extremely literally and find ways around it or turn things on their head. Somebody earlier mentioned the paperclip example. I'm not sure if you're familiar with this, but Nick Bostrom, I think it was, proposed a challenge, philosophical challenge. Imagine we gave a robot the task of make as many paper clips as possible. Sounds pretty benign, right? But if it's really trying to maximize that output, why not kill all the humans that they get in the way? Why not raise everything but paperclip factories and start building more of those? So things that look benign or have good intentions. The problem with language is that, and we've seen this with the law, right? There are interpretations and there are ways around it. I think you would want to start with laws like that, but you'd want to do a much more thorough analysis of what else needs to be imbued in the consciousness, the brain of a robot, and how do we deal with things that go wrong, right? We're all taught to behave morally and be careful in the difference between good and bad, but we have backup systems for when that fails. We have courts and other things, and they're not perfect, but we can deal with humans when they make mistakes or do things that are evil. We're going to need the same kind of ecosystem, I think, for robotic systems. I don't know how you would build it, but I think something like that is warranted.
So do you think to give AI systems common sense will require embodiment of some kind, like some kind of feedback with the physical world?
That's a wonderful question. And I've seen a lot of discussion of that recently. In fact, I just attended virtually this DARPA principal investigator meeting last week group of people doing or working what they call machine common sense. I don't have a strong view personally, but I think the community generally shares a view that embodiment is really critical in the long run. A lot of what we learn commonsensically is around the physical world, right? You put something on a table, it'll stay there. If you drop it, if you open the cup and turn it over, it'll spill. We learn those things through experience without even verbalizing them. We learn to interact with people generally through physical interaction alike. I think it's pretty important. Now, physical embodiment, you can have humanoid robots, right? You can have Data from Star Trek. You can have snake-like robots or multi-armed robots. Those probably count as well. An interesting question would be, if you built a wheeled, multi-armed robot with a unique vision system, would its common sense that it developed be the same as ours? It may perceive the world differently and know what its limits are differently. I don't know, but I do think that's an important direction for AI, and I think you're going to hear a lot more about it as we go forward. Okay, I think one more. I think we've come to the end of our time, but I'm happy to take another question if you want.
Just a quick one from David. Is it possible that common sense is what humans bring to the AI party? It might be our role.
There are a lot of people who have swerved a little bit from trying to build completely autonomous, independent AI systems to those that would be partners with humans. And we have a lot of role models for that, and we can study and understand social behavior and linguistic behavior. And it may be if we build less powerful AI systems than fully competitive with human intelligence, but we pair them with humans, together the synergy will be pretty spectacular. And we'll be able to do things as partners and maybe even cooperative teams. And there are people who are now talking about what they call human-centered AI. And there are research projects talking about partnerships between humans and artificial intelligence systems. And if the whole world stopped the direction of autonomy and moved in that direction, I think I'd have a lot more faith on sort of the controllability, because the social element and the responsibility to partnership is built in from the beginning. The problem is this autonomous track and LLMs out in the world and self-driving cars, that's out there. I'm afraid we're not going to stop it. So I think that's a very fruitful direction. It'll get us to learn a lot of things that maybe we can then bring back into self-contained autonomous AI. But indeed, since humans have had millions of years of evolution, even though we're not perfect, we've evolved this common sense that we can certainly deploy in a partnership with something that's not so common sense able. These are great questions. Thank you very much. I really appreciate it. And I think with that, Christina, should we wrap up? Thank you all very much for coming. I hope you'll look into further reading on this, and I'd be happy to take your questions offline. So thank you very much.